Hello, ladies and gentlemen, and welcome back to Prospect Charter School's Algebra 1 course. Today we're going to be going over section 3.1, Graphing and Writing Inequalities. So before we can start graphing and writing them, we have to know what they are. So let's go over what an inequality is. So here's our definition. An inequality is a statement that two expressions are not equal. An inequality is a statement that two expressions are not equal. So for an example, 5 and 7. 5 and 7 are expressions, and we want to show that these guys are not equal to each other. So we would say that 5 is less than 7. And then what if we flipped it around and we said 7 and 5? Well, 7 is greater than 5. So this first symbol over here is called less than. And the second symbol that we see is greater than. So less than looks like that. Greater than looks like that. I tend to think of them as like a Pac-Man who is really, really hungry and he's going after the most stuff he could possibly eat because he's a greedy yum 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 monster. So that's one way to remember which way it's supposed to face. Remember the alligator or crocodile or Pac-Man always goes for the larger number because, you know, there's more to eat. Whereas it would never go for the smaller one. There are other ways to remember it, but I just find that one the most hilarious, and I get to draw pictures of monsters eating numbers, and that always makes me happy. Because I know how much you guys love numbers. You wish a monster would come over and eat them all for you. But that's okay. Because I know I love numbers. I love what numbers do for us. I love the technology and advances that mankind has created because of them. And so while you guys might want to eat all the numbers and make them all go away, I'm going to stick around and say, hey, I like numbers. So we've got two symbols so far, less than and greater than. And they're pretty easy to remember. If we have an expression such as 2 and 5, we would say that 2 is less than 5. If we had another expression that 8 and 3, obviously 8 would be greater than 3. But sometimes things are actually equal to each other. And so we have two more symbols. So for an example, let's say we have 4 and 4. Well, 4 is normally equal to 4, but in an inequality, sometimes we want to include a number, but we'll also want to be larger than that number. So to be larger than or equal to, we use this symbol, greater than or equal to. So this means greater than or equal to. And then using, let's see, 2 and 2, we can also say that 2 is less than or equal to 2. So on this one we would say less than or equal to. The only difference is the bar underneath. If you see a bar underneath, that means that it could be equal to. If you don't see a bar underneath, like on these two guys, then it's just strictly greater than or strictly less than. And I don't know why that just popped up. Okay. So you have strictly greater than or strictly less than. You also have greater than or equal to or less than or equal to. Now, do we always have just pure numbers going on? Well, no. Sometimes we have variables. So for an example, what if x is strictly greater than 2? How would we express this? Well, there are a lot of numbers that are greater than 2. 3 is greater than 2, 4 is greater than 2, 50 is greater than 2, 5 trillion is greater than 2. And I don't know about you guys, but I don't want to write every single number in the universe that's greater than 2 because there's an infinite number of them. So what I would do is I would create a graph. So to show all the numbers that are solutions we must use a graph. Now, fortunately for us, because there's only one variable, we only need one number line. So to draw a graph of this, we draw a number line. Of course, it isn't straight, because if it was straight, the world would end instantly. And then we put some numbers on there. So usually right in the middle, we put 0. And then to the right are the positives. So we have 1, 2, 3, 4, etc., etc. To the left, we have the negative numbers, -1, -2, -3, etc., etc. And what we do is we have two ways of showing if we include a number or not. An open circle with a little line going through it, kind of like that, means that you do not include the number at that point. But if we have a solid dot, that means that we do include the number at that point. So for our expression here, our good old friend x is greater than 2, is 2 greater than 2? Well, no. 2 is equal to 2. It isn't greater than, it's not less than, it's exactly equal to. So what this is saying is that I don't want to be equal to 2, but I want to be infinitely close to it. And I always want to be bigger. So what I would do is I'd go to 2 on my number line and draw an open circle above it. That represents that I want to be near 2, but not necessarily exactly at 2. And then I need to show all the numbers that are greater than 2. Well, I know 3 is greater than 2. I know 4 is greater than 2. I know 5 is greater than 2, 6 is greater than 2, etc., etc. So I would need to put an infinite number of points along this number line going to the right. I don't want to make an infinite number of dots, so instead I make a line, a straight line going to the right. And that's how you graph an inequality. If there's nothing underneath, you use an open circle. If there is a bar underneath, you use a solid circle or a solid dot. So the way I remember it is when I was younger, I got hit by a bar, an iron bar. And I can tell you, those things are pretty solid. So if your inequality has a bar, use a solid dot. If your inequality does not have a bar, use an open circle. For an example, if x is greater than or equal to 4, then on my number line, I would start at 4. I know that 5 is larger, so I'm going to start at 4 with a solid dot and go to the right. And if I have x is less than 2, then I would draw my number line. I would start at 2, and I know that 1 is less than 2. So I know I'm going towards 1, but I don't include 2, so I use an open circle. So if you have a bar, you're solid. If you've ever been hit by a bar, you know those things are pretty darn solid. And if you don't have a bar, then you don't have to worry about being solid. It's just air. Okay, now let's see about a simple word problem. So sometimes you have something called a weight limit for something. So for an example, let's say that we are purchasing a folding chair. So a folding chair is rated for, let's say, 275 pounds. Now we need to draw an inequality that represents the weights of people who can use this chair. So for an example, let's say that we have a rather large person who wears glasses. And let's say that this person weighs 325 pounds. Which means he's probably not very happy. And he wants to go up and use this folding chair. Is he allowed to sit in it? Well, we know that 325 is greater than or equal to 275. So what's going to happen when this guy jumps into the chair? Yeah, the chair's going to collapse and it's going to be bad, and then he'll start crying because he can't sit in the chair anymore. Now let's say that he goes on a weight loss program. He goes out and he works out and gets really buff and strong. But of course he still wears glasses. And he goes from 325 pounds to 225 pounds. Now can he use this folding chair? Well, we know that 225 is less than or equal to 275. So yeah, he can use the chair. Now to do this algebraically, since one of our values is changing all the time, we would use something called a variable. And the most commonly used variable is x. So I would say x. And then I'm going to say that it has to be related to the maximum weight of our folding chair, which is 275 pounds. So how do I express that I have to be less than 275 pounds? Well, to use, you would say that x would have to be less than or equal to 275 pounds. And then drawing that on a scale, drawing that on a number line, we would start at 275. And we know that 0 is less than 275. So I would start at and include 275 and go towards 0. So all of those would be able to use that chair. And of course you can't weigh less than 0, so I think we'd probably have a stopping point at 0. and that would be the range of people that could use the chair. All right, well, believe it or not, that's it. That's all, folks. That's how easy this lesson is for today. And because it's super easy, I'm going to give you lots of homework. Yay, homework! Woo! So your homework, if you're at Prospect Charter School, is going to be on page 173 of the textbook. And we are going to be doing numbers 1 through, and it looks like it's going to be a whole lot of them. 1 through 53 odd. And I know what you're thinking. Oh my God, that's a lot. Well, just remember, some of them are going to be like, I have 5 and I have 2. What symbol goes between them? Oh yeah, 5's greater than 2. And you're done. I mean, it's really that easy. So, no complaining. Get to work. Remember, this is section 3.1. Good luck and have fun.